question screen, that's all you see? Perfect. Yeah, you get some thumbs
Yeah,
up there.
yeah, just the
Awesome.
question screen, yeah.
Okay.
Then we can see the presentation on the side.
Okay. I'm going to just adjust a few things here.
Okay.
All right. That should be a bit different. So you should just see the,
Yeah,
okay, good.
so you got no.
Okay, I'm just gonna set up my chat. Okay, we'll get going, Ignatius.
Yeah, go ahead.
Yeah. So welcome. I'm gonna keep my camera off because we're gonna concentrate on the questions today. But here's how it's gonna work today. We're gonna use our chat function quite a bit, and I'm gonna put a question up like this one here: who is the best instructor? And you're gonna get 4 choices, one, A, B, C, and D. And I need you guys in your chat function where it says to, just to me. So it's just gonna be to me. And then I need you to put your answer. So let's just try this one and see how it works here. So if the answer for this one will be D. So yeah, perfect. It should be a direct message. So I got 1 there. So try it, put the answer, good. I got 1 there. D, yeah, good. Perfect. Exactly. So that's how we're kind of going to do it. I'll explain it. If I see a lot of the wrong answer or something that seems really funny, I'm going to kind of explain it a little bit better. We got 50 questions. We got a lot of questions to go through. This was just our practice one. And we'll, if I see something that's really sideways or something that's not making sense to everybody, I'll explain it a little further. This is just to see how well you retain some of this knowledge and how well you guys have been studying. So let's get going on it. And I'll give you guys a little bit of time, but we have 50 questions and only, we have maybe 2 minutes per slide, depending on how we're going to do here. So we'll go with that. Okay, let's start this. You guys ready? Give me a thumbs up if I can see you guys. Perfect. I'm going to put you guys over here so I can see you. Excellent. All right, here's the first one. Get to go here. There it is. Wonder what's... There we go. What do you think? What is not one of the 5 main steps used to treat water? Perfect, it is C. So flocculation, disinfection, diffusion is definitely not one of those in filtration, right? Diffusion is not one. We're actually missing coagulation there, which should be there. So perfect. All right. We talked about barriers a little bit. So what is the final barrier in any water treatment plant? The final barrier. And that's always a question. What's the final barrier? I see lots of C's. Perfect. Good. And that is C, disinfection. What is the term given for the volume and flow of water produced by a well at a given time? This is a kind of a tricky one. Volume and flow of water produced by a well at a given time. Awesome. I see lots of B's there. So it is B, right? It's the yield. If I asked you a given term for the volume and flow of water per meter of drawdown, that would be a specific capacity. Yield is how much that well can actually put out. And the drawdown is basically your static water level to your operating water level. And there's a drawdown in just in meterage and distance. So we're dealing here with just flow, it's going to be yield. And if it's flow and distance, it's going to be specific capacity. And if it's just the distance or the drawdown in meters, it'll be drawdown. So B is our answer. Okay, blank is considered to be any water open to the atmosphere. What is open to the atmosphere here? That's right. A, surface water is always considered open to the atmosphere. Groundwater, of course, is stuff that's not, you know, we could argue runoff water is kind of surface water, but any water that's considered open to the atmosphere is basically surface water. I'm looking for a term here given to a land surface which contributes water to a specific collection point. What do we think? Look at you guys go. It's right, it's watershed, right? So basically, you know, especially here, we've got a lot of hills, a lot of mountains. Water is going to travel towards the stream or the creek or the river that basically is called the collection point, right? So this is going to be B, watershed. And we talked about coagulation a fair bit. And when we talk about coagulation, raw water contains negatively charged unsettable solids called what? Exactly, colloids. That's that cloudiness, right? That's that stuff that stays in suspension. That's that that really cloudy little specks of negative charge repelling each other. And that's why we have to add that positive charge coagulant, right? To bound it all together. So it's B. So which test is a common way to determine a correct coagulant dose? I'm actually making my staff do this today. So they'll be actually doing this test here in a couple hours. And the answer here is going to be a jar test, right? That's when we take those jars and we're going to put different, all the water the same, and we put different doses of chemical in those jars, and we mix them, and we do the exact same thing. We mix and we do a rapid mix and a slow mix, and then we do kind of a subtle to see what would happen. And that's the common way to determine the correct coagulant dose. It's always going to be a jar test. We're doing that here because our snow is melting. It's causing a lot of different water to go into the creek. So it's really important for us to do a jar test today to make sure we're doing everything we need to do. So always the jar test. Aha, here's a good one. What of these items can be used to remove taste and odors? We talked about that, taste and odors. Nice, look at this. Activated carbon, right? And we know activated carbon comes in a number of different forms, and forms being granular, powdered, and a carbon block, or CB they call it, right? And I know some places they'll actually put a sheet of it. It looks like a sheet of wood, and water will flow over it in the channel and absorb the any sort of the volatile organics or the taste and odor creating organics in there. Awesome. Okay, pressure sand filters. We talked about filters. Have the exact same characteristics as which of these filters? A pressure sand has the same characteristics as which one of these filters? See a bunch of B's there. It's going to be the conventional sand. The only difference between conventional sand, this is the letter B, and pressure sand is that the pressure one's delivered with a pump. The pump's creating the pressure, whereas the conventional sand, gravity does the job, right? And that's the only difference. They operate exactly the same. So when they talk about pressure sand, it's just basically the water is delivered via a pump rather than gravity. And that's the only difference there. Back to the activated carbon, we know it's good for taste and odors, and it's a natural material that's not derived from which one of these? Which one is it not derived from? Yeah, you're right. Plastic. Carbon, right? That's your dead giveaway for this particular question. Activated carbon's always fired from something from a carbon base. It's usually wood, and coconut shells are probably the most widely used activated carbon sources. Definitely not plastics or any sort of resins. It's all got to be natural, organic type material. All right. Is this working out so far? Does this make sense? Perfect. I see lots of thumbs up there. Good. All right, so we talk about disinfecting and which one of these parameters here in the raw water can put a demand on the disinfectant. I always see this question come up, especially on the ABC exams. Perfect, it is C, organics. One thing to think about with the organics, the biggest one is going to be color and organics. And that puts a huge demand on your disinfectant system. So one good thing is if I have more color, I tend to have more organics, and that's always a good test if you guys do a color test at all. Usually if there's more color, there's more organics. Not necessarily turbidity, but I find color is your best feature when it comes to dealing with that. But all that, more color, more organics, and 9 times out of 10, you're going to get a bit more bacteria and whatnot too. Little things to think about too, because temperature makes a big difference. So if the water gets hotter, that also can put a demand on here. But our biggest one's going to be organics. So what are THMs? Right, trihalomethanes. And they're disinfection byproducts, right? And these byproducts are created when, or those organics we talked about, combined with chlorine. And this is a family of different disinfection byproducts. We also see a fair bit of new ones coming on the market too, as they're testing more and more. Trihalomethanes are the big ones, THMs, but the haloacetic acids, the HAAs, are also something that's quite, you know, we see a lot in the testing. All right. Ultraviolet or UV, we talked a little bit as a treatment process. What does it use to do the treatment? Perfect, high intensity light. We know that UV uses wavelength of 254 nanometers, and it basically, with that type of nanometer wavelength, it will deactivate the DNA inside the bacteria cells and the pathogens. So it denatures them or basically renders them so that they cannot reproduce or they cannot infect the host. So they work really well. The water has to be super clean though, because if it's not, then that bacteria and whatnot, they could hide behind little parts and pieces in there. And so you got to be careful with that. In our first lesson, we talked a little bit about negligence and all this type of stuff, right? Your duty as an operator or manager in providing water to your customer comes with a bunch of different terms here. So which of these terms describes a general duty to exercise care? Yeah, see, absolutely. You're going to show due diligence, and any sort of negligence or action against you or your operators is they're going to ask you, you know, how can you prove to us that you did everything you could possibly do to make sure that this event didn't happen? So for example, if I had a chlorine pump and the chlorine pump was in ill repair and I chose to leave it, that's almost being negligent. But if I fix it and I do the best I can or replace it and make sure that pump is working well and it's maintained and I have records and my staff are trained to run this pump, then I am doing everything I can do to provide the due diligence, which means I'm doing everything I can possibly to do my job. So yes, it is C. Safety, of course, big things, always being safe on the job. What is not a way to control possible hazards at work? Not a way. Yeah, definitely A. Don't ignore the problem. One of the biggest things, and it's in order in this particular question, is engineer it out, right? So if I have a confined space, is there a way that I can make that space safer? Or do I even have to go in that space? You know, that's engineering it out, making sure that, do we actually have to do this dangerous act? Or is there another thing we can do that's safer? And that's engineering it out. And that always comes first. That's the first thing you should always think about. The second one is, if you can't do that, you're going to put some sort of controls in there. And that could be procedures or something to make it safer. That could even be putting a guard around it or a fence around it or something to protect you and your operators from being, you know, hurt in this particular instance. The last control measure is always going to be your PPE or your personal protective equipment. And that's going to be your hard hat, your gloves, your masks, your eye protection in your boots and whatnot. So always make sure that you're keeping safe out there for sure. Just gonna move here. Go. There. Okay. I just got so many screens open here. Okay, perfect. Got it here. Okay, so again, back to some of the terms. What's the term that describes the chlorine residual obtained after the water treatment process? This is a tricky one sometimes. The chlorine residual obtained after the water treatment process. Perfect. It's going to be B. It's funny, we had to talk about this. I have a number of my staff, they're going to be writing their ABC exams today, actually, this afternoon. So we actually went through this. Primary disinfection is basically deactivating the bacteria, right? It does the job of oxidation or disinfection, and that gets all the bacteria out of there. And that's the job of primary disinfection. Secondary disinfection is that residual that's out there to protect the system. So always remember that. So when it says chlorine residual after the water treatment process, that's leaving your process, that's out in your system, protecting your system is always secondary. So knowing that primary kills the bugs and secondary leaves you with that protection out there, or that residual. And that's the word you're going to look for in your test, residual. And that tells you that's secondary disinfection. We talked about membranes. Here's all those fantastic membranes we talked about. And which one of these, though, is a lower pressure version of reverse osmosis? This one's a tough one. Think about it. Lower pressure version of reverse osmosis. Oh, I stumped some of you. Good. So membranes are always ordered in order of pore size, which means that as we move from the smallest pore or biggest pore size to the smallest, less things can get through, right? The number one, the one with the smallest pore size and the one that removes everything is reverse osmosis. That is the one that is the most, takes the most out. Behind that, nanofiltration. So the answer here is going to be C. Then ultrafiltration, and then finally microfiltration. Okay, so ultrafiltration will take bacteria out, microfiltration will take bacteria out. Ultrafiltration will start taking out all the non-dissolved things, which makes it the best choice for water treatment as a whole. And then nanofiltration is a lower pressure version of reverse osmosis. It'll take out some of the minerals, not all of them. And again, finally, reverse osmosis takes everything out. And we talked about reverse osmosis water being not the best water to drink because we do need some minerals in our water to be safe. Not just for you guys to drink, but also for our pipe network and our pipe systems. Water without minerals it's very corrosive. So always keep that in mind. So the answer here is going to be C. Here's another tough one. The questions are going to get tougher and tougher here. Body coat filters. And you're going to see that word in the AWW or the ABC tests. Body coat filters use which one of these things? And then we'll talk a little bit about it.
Body coat.
Yes.
See?
I put some of these in here just to kind of get a good discussion going too. Okay, so with this one here, so there's some terminology here we'll talk about. We talked about the diatomaceous earth filter, the DE filter, and it's a body coat filter. So sometimes in the ABC test, I see the word body coat. So that's why I wanted to talk about that. It is a diatomaceous earth filter or a DE filter. It uses a filter aid support media. And that in this case could be diatomaceous earth. So you find that question quite a bit, and it's really tricky with terminology. So a body coat filter is basically a filter that uses a diatomaceous earth or some sort of product like that. And it's basically, think of it like powdered membranes. So the answer here is going to be B.
Just now, anyway. Look at what.
Who's got their microphone on here? Thank you. All right. So this question is going to be body coats are diatomaceous earth, and the answer is going to be D. Absolutely. Sand media is used in your conventional sand. Mixed media is also used in your conventional sand. Manganese green sands for iron removal. So the answer here is the filter aid support media, and you can make a little note that a filter aid support media also is called DE or diatomaceous earth. That's always a tricky one. So the answer here is D. And if you're listening what I just said, you'll get this question pretty quick. Manganese green sand filters are used to remove which of these things? Manganese green sand filter. Yeah, it's an easier one. Iron and manganese. And the two activators, right? So what we do is we use an oxidizer. And the oxidizers of choice here, first one's going to be chlorine. That will be added to the water. That converts the iron and manganese from a form you can't see to a form you can see. And then that could be filtered out. The other product that's used is the potassium permanganate. And that's also used to do the same thing. It's used to deactivate or bring the reduce the iron and manganese so that you can see it. And then if I can see it, I can get rid of it. And that's what this does. Okay. We talked a little bit about surface water earlier. Which of these items does not represent a parameter of surface water? So which one of these surface water doesn't have? What do you think? Okay, so surface water. Surface water has color because it's in contact, right, with the leaves and stuff. So yes, that's not the answer. It has suspended solids because it's sort of flowing over the land. It's going to pick up all that stuff. So that's not it. And because it's open to contamination from mammals, yeah, it does get microbiological content. But what it doesn't have is because it doesn't go into the ground and get in contact with the rocks, our answer here is going to be C, high hardness, right? And you got to think where hardness comes from. Hardness is calcium and magnesium, right? And you're going to find that in the rocks, and that's for more of the groundwater. So surface water, again, keep in mind, lots of color. And always think of leaves in a cup of tea, right? And suspended solids, because you're flowing water over land, it's gonna pick up dirts and all the nasties. So that does happen a fair bit. Hardness is your answer here. We talked about in one of our first lectures is that about the cycle that shows the relationship between the surface and groundwater and how the water moves through the atmosphere. Which one of these is that? This is a fairly easy question, I know. But you'd be amazed how many people get this one wrong. The hydrologic cycle on this one, you guys all got it there with B. Yeah, it's your relationship, right? Stuff evaporates into the sky, makes the clouds condensate, it falls as precipitation, rain for you guys, snow for me, and on the ground it goes. And it can do one or two things. It runs off and gets into surface water or percolates into the ground and becomes groundwater. But everything's connected. So groundwater is always connected with surface water and vice versa. So we always have to take care of our whole system, because if there's one part that's contaminated, it could potentially contaminate everything. All right, this next one's going to take a little bit of thoughting or thinking process here. Think about this one. If a pressure gauge in your plant or a pipeline reads 14.7 PSI gauge, how high in meters above the pipeline is the hydraulic grade line? I'll let you think about that one. What do we think? I see some answers floating in. This is why we're doing this review, you guys. We'll get this sorted out. It's a tough one. Okay, so here's what we're going to do. When we got one atmosphere, I got one atmosphere. And that's an atmospheric pressure pushing down on all of us right now. And the magic numbers is 14.7 PSI is one atmosphere. 14.7 is pushing down on us all the time, right? And 14.7, when we talked about, is equal to 10 meters. This level is equal to pressure, right? It also equals 101.3 kilopascals, kPa. These are all the same. It's one atmosphere. It is also 30 meters, or 30 feet, sorry. These are all the same. So the whole idea here is that levels equal to pressure. In some instrumentation, what they'll do is they'll measure the pressure in the tank and correspond that pressure in that bottom of the tank to the level of that tank. And they use that's part of level transmission. So atmosphere is super important. One atmosphere is equal to all of these things. So in this case here, 14.7 PSI, and we talked about gauge, right? That's just what it means at the gauge. That means that it's 10 meters. So that's our answer, 10 meters, right here. back to the hydrological cycle. Trees and other plants take up water from the ground through the roots, right? And return it to the atmosphere using which of these processes here? Ah, perfect. D, absolutely. Transpiration. It's like evaporation off the leaves, but it's transpiration. It comes through the roots and it basically returns to the atmosphere through the trees. Awesome. Right. You guys should get this one. Come on. Which item is the disinfection process of passing water by high intensity lights? Right on. D, absolutely. Right. Don't get it confused with ozone. And ozone's going to be uses electricity, right, or a corona discharge, and it's almost like lightning. Whereas ultraviolet uses that 254 wavelengths. They work very differently, so don't get them mixed up. All right. How about this one? I think we should get this one. This item is a powerful oxidizing and disinfecting agent generated on site by passing oxygen or dry air through a system of high voltage electrons. What do you think this one is? Ozone. You got her. Really good oxidizer, right? And your trick here, when you write the test, they'll talk about it as a powerful oxidizer. It is one of the most powerful oxidizer, ozone, and second only to fluorine. And fluorine isn't really used in the water treatment industry, but it is one of the best when it comes to oxidizing. So I look at this as probably one of the best oxidizer, and it can be used really successfully to oxidize any sort of bacteria and or any organics in that water. It just works so well. Expensive though, and it's not widely used. A lot of the swimming pools here use ozone to clean, because of course a swimming pool, you get a lot of nasties in a swimming pool. So, all right. This one should be pretty easy. So the adequacy of disinfection is judged using the product of the final residual concentration in milligrams per liter in the contact time in minutes. And this is called which of these items? This is a real, Shannon, think about that one for a second. So two things, right? When I add chlorine to water, what they're going to look for is two things. What my chlorine residual is going into the water. Okay. And then it kind of goes to a chlorine contact tank. And that chlorine contact tank is designed to have the water in the chlorine mix for a certain amount of time. And so it's important for our first customer to have water that has been properly mixed and properly contacted with a disinfectant. So in this thing here, I look at two things: the final product of a chlorine residual concentration in milligrams per liter and the contact time in minutes. And this is called CT time. This is D. One of the questions you might come up with is, if my reservoir or clear well does not have enough contact time, what can I do to make it better? And this is where we put baffles in, right? So if I take my, where's my drawer guy? If I had my chlorine contact tank that looked like this, normally water would come in, sort of kind of mix in here, and out it goes. If I wasn't getting enough CT time, what I'd end up doing, I would actually put baffles in. Like that. Now the water has to travel and it increases contact time. So that's a question you might come across. How can you increase CT time, right? You actually either A, slow the water down or have more contact or have more chlorine residual. And those are the things you got to think about. So this is CT time, takes into account chlorine residual and the amount of time that the water is in contact with the disinfectant. All right. Oh, here's a single one. I like this one. Which of these items are single-celled microorganisms that possess no well-defined nucleus and reproduce by binary fission? What do you think of these nasty things here? What are these single-cell microorganisms? They have no defined nucleus and they reproduce by binary fission. Oh, a whole mix of answers here. I think I got one of everything. So let's go through some of these. This is why we do this. Okay, so colloids is out, right? We know what a colloid is, so we know that's not it. A virus needs a host, right? You're the host. So that's basically how it reproduces. It needs a host, so we know that's not it. That leaves these two guys. The difference between these two guys is that a protozoa has a nucleus and it has all the stuff on the inside. It's well defined. So we know it's not that. That leaves us with bacteria. Bacteria is a single cell microorganism and it has no well-defined nucleus. So here it's going to be C. The thing that you're going to think about here is that single-celled and it's not well-defined. And that is your key when you write your test. Binary fission too as well, that's how it reproduces. But think about that, the bacteria, that's your most simple form. Protozoas are a bit more advanced, right? They got usually a tail on them, right? And they got like a flagella and all this stuff, and it's very, very defined. So that's the biggest difference between them. Bacteria are pretty easy. So the answer there is C. Ooh, this is an interesting one. Out of these things, what is the most important consideration in providing adequate storage capacity in a water system? So read this really, really carefully. Good job, Nicole. I like that one. What is the most important consideration? Read the question really carefully, you guys. This is a tricky one. Okay, so when we looked at this here, our number one thing is always going to be providing water quality, right? I mean, that's the system as a whole. We want to do that. To prevent any backflow, we want to keep water pressure in our system. The wording here is adequate storage capacity, which means, do I have enough storage up there? We already know we got to do this. Turbidity doesn't really play into it. We store water for a number of different reasons. For emergencies, for water breaks, power outages, and fire protection. So when you look at this one here, fire flow is the answer. Right? The most important consideration in water treatment and delivering product to our customers is definitely going to be water quality. But that's not what the question's asking. The question's going to add is providing adequate storage. And that's what I take these questions right off the exam. So really be really careful with how you read the question. That's why I put some of these on there. Super important to provide the adequate storage capacity, and because it's for fire protection. The secondary to it would be water pressure, but the number one is going to be the fire flow. Okay. Ooh, I like this one. Which of the following contributes to the creation of algae blooms? Okay, algae blooms, like algae's plant, right? And plants grow. So you think about what out of these things are gonna help a plant grow, right? I would definitely say nutrients. The nutrient. And turbidity is not gonna make a difference. A decreased air temperature won't, an increased will. But decreased, no. And wind, no. Algae is a nasty thing. Think about that, right? You don't want algae. Algae causes a whole bunch of issues for us. Especially when it comes to pH, right? So we know at night, algae can produce water that's in acid. And that can kill fish. It can really make a mess. During the day, the pH will change back because it's now putting oxygen back in the water. But at night, it's a pretty nasty thing. Also, too, this will clog filters. And when you have little bits of algae and you add chlorine to that, it gets really nasty, right? You can basically really, really smell it. It's terrible. All right. How are we doing so far? Everybody, is this helping a little bit? I hope. All right. It is, we'll take a quick 5-minute break here. Ignatius, we'll do a 5-minute break and we'll be back at, I think it's gonna be 9 o'clock your time.
Okay, 5-minute break.
Thank you. I have to let my staff in here. They're all banging at the door. It's 6 a.m. here, so they're all starting work. So that's why I usually take a little break around this time. All right, so hopefully this is working. And well, we're question number 30 out of 51. So we're making good time here this morning. Now, there's some of these questions are going to again get more difficult as we keep going, but we'll chat about that when we get there. In metric system, the unit of pressure, we talked briefly about that when we talked about that 14.7 psi. What is the metric unit of pressure known as? What do you think? Metric unit of pressure. Okay. Real mixed bag of tricks here, guys. So let's look at this, right? Yeah, it's A. We see it usually as a kPa or kilopascal. That is the metric. The PSI is the imperial. But the metric is the pascal. Just like the foot is imperial and the meter is in metric. So the answer here is Pascal A. All right. So we talked a little bit about a hardness and how to get rid of hardness. And one of the ways to get rid of hardness is to add a chemical. And we're going to add these chemicals here. It could be lime or caustic soda or soda ash. What do these do to the pH of the water? If I add one of these chemicals, they all kind of do the same thing. What's it going to do to the water? Okay, let's talk about this because I see a few different answers. When we add any of these type of chemicals, lime, caustic soda, soda ash, right, or sodium hydroxide, any of these chemicals are all about the same. And they're all used to increase the pH. So the answer here is going to be C. Those are all pH increasers. When we talk about where we use it here is two things. We want to make sure that pH is correct, leaving our treatment plant so it protects the pipes, right? The other thing is that we use these chemicals a lot in the water softening. You know, thanks, Dwayne. What we end up being is if I increase that pH, and if I increase it to like almost 10, then calcium and magnesium will actually fall out of the water. Very similar to what happens when I add chlorine to water and the iron and manganese start to appear. The same thing happens with hardness. When I increase the pH to like almost 10 using lime, caustic soda, or soda ash. Some plants, if the water is very soft, right? So the water comes from a creek and it doesn't have a lot of calcium and magnesium in it. And if I put that water, remember I said that water that doesn't have minerals in it is very corrosive. Sometimes I'll add a soda ash or something like this to the water to increase the pH and give it more calcium carbonate so it actually stabilizes the water a little bit more. But in this case here, all these products will increase pH. What would lower pH? You put it in your chat function here. What would you use to lower pH? Give me one idea what you would use to lower a pH. What do you think? What would you use to lower pH? Okay, chlorine gas could work a little bit. What would work even better? You're on the right track with gas, but think about that a little bit. What could lower pH? And it's really widely used, more widely than you probably ever think it would be. Zinc a little bit, but not enough that we would have to lower it. If I had too much pH coming into my plant, how am I going to lower this? Okay, think about this now. You guys have all had soda pop, right? Basically, soda is sugar and it's syrup, right? It's sugar and water, basically. So if I had sugar and water in my pop can, it's not going to be acidic at all. If I'm going to add CO2, and Nicole, you just said that will lower pH. That's why cola and soda pop is so acidy, is because of the CO2. Now I saw the word muriatic acid on there. And that's another one that's quite widely used in water treatment plants. They use a liquid muriatic acid, and that will bring pH down. It's difficult to use because you got to handle an acid. So bigger, larger water treatment plants will add carbon dioxide. They'll bubble it in, right? It's almost like adding it to cola or sparkling water or anything like that. It acidifies it or brings the pH down, right? And that's one of the big ways to do it. It's a little safer too, CO2, but that's what it is. The carbon dioxide brings that pH down. So always think about that. One of the big things when we talk about pH is that the chlorine, remember we talked about chlorine. Chlorine works well at a pH of about 7.5 because there's acid created and an ion is created. At 7.5 pH, there's lots of this acid stuff. And this is what kills that bacteria. That's the stuff. Because it breaks down into an acid and it oxidizes the hell out of everything. It's fantastic. Now, as the pH goes up, and now the pH is going to be, say, 8.1, there's less acid and more ion. Ions don't do a very good job. Not good at all. So you have to add so much more chlorine because it's not working very effectively. The less pH, the better this works. And this works really good. As the pH goes up, and as you start getting over 8, more ions, not so good. You might get that as a test question. I see that all the time. The lower the pH, the better that chlorine works. Also, too, some coagulants work much better at a lower pH. So when you do coagulation, make sure that that your coagulant of choice is going to work in the pH that your water is coming in at, or you have to make an adjustment. They had an issue here that my pH was almost 8 coming in, and the product we're using for coagulation was working at best at 7.8 pH. So we weren't getting very effective color removal. So always be aware of what your pH is and how you can adjust it if you need to. All right. Oh, here's a good one too. We talked about alkalinity a fair bit and coagulation. So what is it defined as? What do you think? What is the definition here of alkalinity? You guys still there? What do you think? Okay. I'm seeing some floating in. What do you think?
I missed you. Oh, sorry.
CB. Seeing some all different ones coming in here. Okay, so here, the answer is C. It's resist the pH change. Here's why. So basically what we see is what alkalinity is, and this is going to be probably on the test too, is something called CaCO3. And this is called calcium carbonate. And the calcium carbonate is a buffer, right? It's good stuff in the water. It makes the water really stable. Then the more calcium carbonate in the water, right, the more it will resist the pH change, which means that water is really stable. So we want that. Sometimes we have to add stuff like soda ash and the pH stuff that we just talked about, but we want alkalinity because it stabilizes the water. This is good for our water system when it goes out in the pipes. So our pipes don't, water without calcium carbonate is really aggressive. So we want some of that in there, and it stabilizes that water. So super important. The other thing is that alkalinity also is for coagulation. So we need it. It's the gas that makes the reaction go. We talked about if this is aluminum in here, and I got the 6 arms, and this is my coagulant, right? And basically what happens is I'm going to take the OHs, and that's basically calcium carbonates, out of the water. And I have to use 6 of these up. There's my calcium carbonates. So if the calcium carbonate's in the water, it has to join up to all these arms to make this coagulant work. So you remove it from the water. So if it's not there, and for some reason, say I didn't get this arm filled, this isn't going to work. You have to have all 6 filled. So if I don't have enough calcium carbonate to fill all the arms, this thing's not going to work. So super important that we have enough calcium carbonate or enough alkalinity to make the coagulation reaction work. And it protects our pipes. It's so good. All right. Oh, this is another great question. What do you think? How many times do you have to rinse a microbiological sampling bottle? Okay, we talked about this last week, and there's really never ever rinse it. When you take samples, you do, absolutely. But microbiological samples, never. In those bottles, there's a white powder in those bottles. So the whole idea is you take the lid off, be very careful not never to touch the lid or the threads, and it has, you're right, sodium thiosulfate in it, that white powder, and it's there to deactivate the chlorine. You're going to get a funny test if you rinse all that stuff out and all of a sudden you're putting water in there that has chlorine residual in it. Well, it kind of negates the test. So super important that you do not flush that white powder out, and it should be a one-time easy sample. Remember I said that you adjust your flow on your tap so it's very, very almost pencil-like. So there's not a lot of splashes. And basically you fill that bottle to the mark, 100 ml mark, super important, but never, ever rinse it. If you rinse it, the sample's no good. You start again. Never rinse the bottle. Thanks, Dwayne. So never rinse that bottle, you guys. Always, it's just a one-time thing. That's it. Okay, so distribution. So we're out there. What is the main purpose of avoiding the dead end mains? And we talked about all the different styles, right? You got dead ends, you have looping, and you have a grid. And those are the three big ones. So why do we do this? Well, it looks like I'm getting some answers. Good ones. Awesome. Again, you're right, exactly. You don't want stagnation or bacterial growth in your distribution system. Absolutely. If you do have dead ends, then you need a program in place to make sure that you're flushing or you're keeping tabs on your water quality. I would always be checking your dead end mains. Because if there is going to be bacteria growth in there or something that's happening, you need to flush that area and keep that water fresh. Your biggest problem out there in the distribution world is a large main with very little usage on it. And it provides a lot of headaches for taste and odors and color and bacteria growth. So we got to make sure that we're always on it. Good one. Everybody got that one. Oh, that is a good one. Read it very carefully, you guys. Read it very carefully. This item here represents the difference in height between a free water surface and a reference elevation called the pump center line. This comes right from the test question and is super important. What do you think? Read the question very carefully. Everybody's quiet out there. Good answer so far. Thank you. Awesome. All right. You guys got this. So think of it this way, right? So I got a bin of water. Yes, the water's pink. You got a pump. That's my pump. And into another tank of water up here. So let's use my blue water. So basically, if I'm going to pull water, what they call a free water surface is a water open to the atmosphere. So this would be a free water surface here, and this would be a free water surface here. I'm going to pull water from a free water surface to the center line of that pump. This is your right. This is suction head. Right there. Perfect. If I had to, from the pump center line to a free water surface, that is now discharge. So that's right here on this side of the pump. The total from this surface here to that surface there is the total. So that's how you have to remember it. Free water surface to the pump is always suction. Pump to the free water surface is always discharge. The total from start to finish is going to be total. Good job on that one. That was a tough one. Ooh, I like this one. Think about this one too. Electrical pressure. Electrical pressure. Think about that one. What do you think? Ooh, I see some different ones there. Okay. Let's go through that. I look at it like electrical circuit, like a water, right? We always have a pump. And our pump provides the pressure in our line. You know, sometimes I'll have a check valve here. And it's going to in our conduit. So basically I have a pump providing pressure. It's going to make water flow in a pipe. And sometimes they're going to have resistance in a check valve. So in an electrical circuit, right, voltage is going to be the pressure. Current is going to be the flow. Resistance is like your check valve. So D is our answer here. Current is flow. So for those who answered A, current is always flow. Voltage is pressure. Good one. I see this question every single time, and there's a part B to this question, which I'll ask you guys as well. But let's do this one. The most common electrical power source used to supply motors in the small water system or your water treatment plant. What is the most common electrical power source? Okay. I see some different answers there. So let's talk a little bit about that. The answer here is going to be B, and let me tell you why. The trick here is read it really carefully. Anything with direct current. So that would be this one and this one. This is all battery. Always battery. So when they talk about direct current, it's a battery. So we know we don't normally power our pumps with a battery. So we know those are out right off the bat. There is no such thing as 8-phase. So that's out. That's out. So single or 3-phase alternating current. Alternating current is your typical voltage. That, you know, it could be 110, 220, 460, 600. It's all different, but single or 3-phase. Difference is in a 3-phase is that power will come in with 3 fuses. And each of these fuses will power a different part of the winding of the motor. So I have a motor in here and they'll have different packs on it. that'll make the rotor. So inside your motor, you'll have those electronic fields in here. And the stator in the middle is going to spin, right? It spins in a direction. Each of these fuses, right, is going to supply voltage. And that's three-phase. I can have a single one, but this is what three-phase is. And basically, this is going to provide, you know, say this one is going to provide it to this guy, this one's going to provide it to this guy here. Yeah. And the motor's going to turn. If one of these died, will this keep running? It will, but not really well. It'll have a hard time getting going because it takes all three of these to get this thing to start. But once it's spinning, if I lost a phase, I can still run. And that's a question you might get. If I lose a phase, my motor will still run? Yes, it can. It's just going to run really bad. And it's going to be really, really hard to start. Because it relies on these three coils to be energized in order to keep that thing moving around. You're hoping that this gives it enough momentum that it won't need to be boosted past that point. So that's in essence what three-phase is, right? Think of it. It has three different power sources. So because it has to provide a lot of power. A lot of the bigger motors are three-phase and they'll have three actual fuses. But it is, B is our answer here. Let's do some math, get your calculator out. What is my average for this particular flow records? Right, answers are trickling in, that's good. We're looking for average. We're looking for average. Right on, I'm seeing stuff come in. Good, good. Okay, so any sort of average, you're going to add the terms up. And because there's 1, 2, 3, 4 of them, you divide that by 4. Your answer should be here, B. And that's what we're going to be looking for average, right? Add the terms up, divide by the number of terms, and you get your average. Ooh, this is a good one too. If I have to express 12.5% solution of hypochlorite as a decimal, how am I going to do it? What do you think? What's it going to be? Good job, Nicole. Awesome. Right on. Good. Okay, remember though, anytime you have a percentage and you want a decimal, you're going to divide that by 100. By 100. So when you divide that number by 100, you are going to get D. Same thing if I have to go the other way. If I wanted to make this a percentage, then I need to times that by 100. Always by 100. Good one. Oh, this is a good one too. All right. I have a cylinder tank. It's 3.6 diameter and about 5.4 meters high. If I totally fill this, how many liters do I have? Ooh, let's think about that one. This is a two-part question. I'm really going to make you think here. Now I'm going to show you a little shortcut on how you can do this. This could be used for a cylinder tank. For those of you who got the answer, C is the answer, or it's the closest answer. So let me show you an easy way to do this without too much thinking. If I had a cylinder tank, this is my cylinder here. I'm not a good artist, but you get the idea, right? What you need to do here, and here's what I usually do. If I go 3.6 meters times 3.6 meters times 5.4 meters. What I'm going to be looking for here is I got 1M, 2M, and 3Ms. When I actually times this all together, 3.6 times 3.6 times 3.6 times 5.4, I get an answer of 3.6 times 6. I get an answer of 69 point. That's what comes up on my calculator. When I'm solving for a cylinder, I like using the rule of 0.8. So if I times this number here by 0.8, I'm going to get 55.98 cubic meters. I also know that I want liters. So I know that 1,000 liters is equal to 1 cubic meter. Therefore, if I take this answer and times it by 1,000, I'm going to get an answer of 55,000, I think it's something close to that, liters. Now that's pretty darn close to this answer. Now, a lot of people use the pi method and all this stuff, but I always use a rule of 0.8. And that says if I take my diameter, times it by my diameter, times it by my height, and take 80% of that or times all this by 0.8, I'm going to get an answer that's pretty darn close. And that's an easy way in the field to think about that. The second part of the question, like I said, was converting your cubic meters to the liters. And always think about that. If you ever get stuck on that, think about how big a meter stick is. So if I had a cube that was a meter stick by a meter stick, that's a big cube. So it takes 1,000 liters to fill that cube. That's how you think about it. Don't mix it up. Always think, okay, yeah, a cubic meter is a meter stick by a meter stick. So I have to fill that cube full of water. It's going to take a lot more than 1 liter. It's 1,000 liters. Again, use whatever method works for you, but that's something to think about. There's some other ways to do it. And I know the other Mike, when they taught math, there was some, I think you guys are pretty strong with the math stuff. Ooh, demand. This is the demand question. Always get a demand question. So think about that. What's my demand? What's my demand? I see lots of D, good. And it is, this is really simple math. I'm gonna put in 175. I'm left with 0.25. I've used up 1.5. That's the demand. So when they're asking for demand, that's what they're asking for. You're always going to get one of those questions. So always think about that. Always demand, right? Demand is also called your combined chlorine. We talked about that, right? Chlorine put in, your demand is your combined. What's left over is your residual. Oh, here we go. This is a good one. I got a reservoir, it's got 695,000 cubic meters. That's huge. It's 62% full. How many cubic meters are in this reservoir? How many cubic meters if this reservoir has 62%? What do you think? Fantastic. I'm seeing a lot of good answers there. Keep in mind, really, first thing you're going to ask for, they're going to ask how many cubic meters? M3. So make sure you didn't choose that guy, because that's not M3. Your answer's right here, folks. It's A. Cubic meters, 430,900 cubic meters. Read the question, make sure the answers and the units make sense. So always make sure. That's a dead giveaway. Read that question super carefully and read your answer super carefully. That's the biggest thing about writing an exam for ABC is reading that question very, very carefully and making sure that you know, you're getting it. Okay, we talked a little bit about this. Term used to measure the difference between the static water level in your well and the pumping water level. We talked about this earlier today, actually. What is it? All right, I see a bunch of eights. Awesome. And it is, right? That is your drawdown. When I have this line here to operating line, have my well here. This is the static here. This is the operational. It will make a cone of depression, just like in your bathtub when you pull the plug, right? It will make that. The radius of influence is how far out you influence. This is the cone of depression. This is your static line. This is your running line. The distance between the two is your drawdown. All right. Okay. The most common coagulants are a type of metal salts called what? Which one of these is the most common coagulant used out there? Perfect. This is going to be C. Aluminum sulfate, also called alum, is the most common. Ooh, here's which unit of measure that describes the degree of acidity or alkaline of a solution? What do you think? The acidity or alkalinity of a solution. Nice, I see it. Definitely pH right here, D. Ooh, here's a good one. Which item is accomplished by exchanging calcium and magnesium cations against a sodium ion? What's that called? And again, a lot of time read that question because the answer could be in the question. Read the question carefully. Exchanging calcium and magnesium, which is hardness, against sodium. What do you think? This is ion exchange, C. It's a way to soften water. You're going to exchange the calcium and magnesium for sodium. Ion exchange. C. What's a DPD test? What's a DPD test? What's it good for? Oh, that was an easy one. Everybody got that one really quickly. Good. Chlorine residual, A. Absolutely. Good one. Ooh, here we go. Water that requires a large amount of soap to produce soap suds is termed which one of these waters? Yeah, hard. And hard water comes from the ground, right? It's hard water, hard water. It has lots of calcium and magnesium in it and makes, you have to use a large amount of soap. Hard water. All right, we're getting to the bitter end here, you guys. Doing well. Okay, also, I see this a lot on the test. Small gaseous chlorine leaks around a chlorinator or anything can be detected by the use of a solution made from which one of these chemicals? Awesome. A, definitely A, ammonia. It will, and if you, I usually just saturate a sponge, put it in a little bottle, and that vapor will dictate if I have a leak. You'll see a little white, a little bit of white smoke looking. And then you know that you still need to tighten things up or things aren't proper. Because the last thing you want is having any sort of chlorine leak, that's for sure. All right. Aeration in water treatment plants is used to do what? Aeration is used to do which one of these? What do you think? Aeration. Yeah, it's B. You're going to want to get rid of stuff called VOCs, volatile organic. And they're in the form of dissolved gases. So B is the answer. Perfect. Stop share. Back up here.
Layu is big gut and related areas. That's right. So you took that so the
All right, everybody, I think that's the end of that test. You did 50 questions. I think you guys did really well. There's a few things you guys have to study on, but I think majority of you guys did really well. So really proud of you. You made it through 12 weeks of hard, lectures and listening to me. And I appreciate that. So I think you guys are in good shape to go into a test. Take a look at that math that you did with the other mic and go through all the processes right from surface water, all the processes in your lectures, through all the treatment processes, all the stuff in the distribution that we talked about, all the lab stuff, all the stuff in the source water with the hydrology, and go over it really good. My advice to you guys is read the question very carefully. Take your time. Read that question, looking for what they're actually looking for. Because if you go too fast, you will miss what they're asking you. And then everybody falls into that. So I can't stress that enough, to read the question 1 or 2 times and then answer the question. Take a look, if there's a math question, look at the units that they're asking for and ask yourself, what are they actually asking for before you just run and throw an answer on there, because some of those questions can be really tricky. So anyway, well done. Thanks, Ignatius, for the opportunity. I appreciate it. It's been a lot of fun for me.
Yeah, well, thank you so much, Mike. I don't know how well we can show our appreciation for 12 weeks of being up a very early morning to do these tutorials for us, and that's
Lots of coffee. Yeah.
Well, I'll have to find you some of the finest coffee in the Caribbean to send you.
And there you go. I'd be all over that. So, but everybody, thank you for listening to me. I wish you luck in the test. It's been a pleasure.
Thank you very much. You have a good day, and we will keep in touch with you, Mike.
Sounds good. Thanks, Ignatius. Take care, everybody.
Okay. Everybody, all the best in your test coming up on the 16th. I think Suzanne should have been in touch with you by now. Best wishes. If you have any problems, send us an email to Mrs. Joseph, sjoseph@cawasa.org. Okay, bye.
Bye, everybody.